Welcome to Shrav's technical series. In today's discussion, we'll start the session 5 of the Rust-based ticker plant implementation. In session 5, we will discuss these topics. First, I'll demo the work done so far. So this is the data flow diagram. In the demo, I'll show this data flow diagram. So we'll send a message from Angular UI client over WebSockets to the Backend-node.js server, which is an Express.js based WebSocket server. It's again socket IO. And then the message is passed over NSQ message queue to the Backend-rust server, which is our ticker plant. The ticker plant will process the message and send it back over NSQ to the Backend-node.js. And the Backend-node.js server will send the message back to the Angular UI client. So today I'll demo this message in the Angular UI client in the debug console. The message is not yet wired into the UI, so we see the message in the debug console. Then in a subsequent session, I'll plug in that in the UI. So I'll switch back to the Angular UI. This is still my local version. Haven't pushed it to the production server yet. So this is in the local version. So we have the leveraged funds screen here. Since it's not in production, we'll not spend much time on the UI. So in the UI, when I click on this button, it will send a message over WebSockets to the Rust backend. So I'll switch to the Rust VS Code. So in Rust, we have the VS Code server running here. So let me press some enters. So I already processed the message, but for this demo, I'll send a fresh message. I'll go back to the UI, click on this link. So the UI is sending messages to the over the WebSocket. So it sent all these messages, and this is to the Rust backend. It's sent over Rust backend socket IO topic. Then the message went to the socket IO server in the Node.js, and the Node.js server responded with the response. So this download URL, that means the message came from the socket from the Node.js socket IO server. So I'll focus on that message, which is here. So I'll focus on this message. So this message came from the Rust backend, and if I expand, it shows the message. So that is the message. Now I'll go back to the UI. I pressed enter here. So if you see here, the message came to the Rust backend. I did cargo run, so it is running right now, and the Rust backend sent this message, sending the processed message on NSQ, and it sent this message. Right now we are getting an error. It's an exception message because we are sending these ETFs as the parameters, and these are not leveraged funds, so it's an error. So this message, so there's a traceback and there's an exception message, but for this demo, we're not focusing on the message itself. We just see that the message is received by the Rust backend, and the Rust backend is sending it. So this is what is sent by the Rust backend, and the UI received the same. So if you expand on the parameters, the same. And then there's also the exception message: service error, key error, ETF US QQQ adjusted is not found, key error, right? And it's the same message we sent here. Value, key error, etc. So it's the same message. So with that, I conclude the demo. So these steps work. In subsequent session, we'll make some more updates in the Angular UI, and we'll send the correct message, and then we have to see the leveraged funds analysis in the Angular UI. Now I'll focus on the Rust specific changes made in this demo. We added config.toml support so that we can pass extra config data to the Rust backend process. In the previous session, if you see, we hard-coded that into a config struct. Now we were reading off of the environment variables, but we want to also give support. We also need support of config.toml files so that we can provide configuration over the config files. Then I removed .expect and .unwrap usage in the Rust code. unwrap. Unwrap will cause a panic if there's an error sent by the method. If a method returns an enum of type result which contains the actual value and an error structure, then unwrap would cause a panic because unwrap doesn't know what to do with the error. We removed .expect and .unwrap usages because .unwrap would cause a panic if the error is not processed. So we removed that, and then we use match pattern to match on enum result pattern, and also we use error handling using dynamic error. So I'll switch back to the VS Code, Git graph. I go to the Git graph, Rust code base. I'll open config.rs file. So this is the new code. In config.rs, we added a new struct config, and then the struct config will contain the data we need to add to the toml file. So the toml file would be in this format. The toml file will have a section called config, and under section config we'll have key value pairs. So we added that. So the config had this key value pair Backend-rust topic. Then we added node environment as a new environment variable, and then we added config struct to the app config structure. Then we read the config file using file path, and it returns a enum of a result, either data or error. And then we read the content from file read string using again match pattern. This returns again an enum. So with that content, we go either if it's okay, we return the content C, or we return an error exit 1. Here we read the config file, config file name. We pass the config file name from the environment, and then we read the data into the structure. So that is how we handle the config.toml file. Then we'll go to the data frame service.rs. So now we use the match pattern. Earlier we just did an await on the download object. So now we do the match pattern on await, and we handle the errors okay or error. If you don't handle error this way, then if there is an error, for example, in this scenario, if the key is not found, we download get data frame, and we are downloading download object from S3. If that key is not found, it will throw an exception, and since exception wasn't handled, it will cause a panic and the application will stop. So for that reason, we have to use the match pattern on this one. It will return the return type is result of content comma std.io error. So if it is okay, so using match pattern, if the enum that is returned is okay with download content, we process the downloaded content. If not, we return an error. So we again return an error using box new error. And the return type here is box dynamic error. So a box will create a smart pointer in the heap memory, and it will send a dynamic error, the dynamic error of type error, which is dynamic in nature. So you could pass any type of error which implements std.io trait. So that's the advantage of using boxed in error, because we can dynamically pass any error. For example, in S3 case, we get Rust S3 library specific errors. So we cannot trace that Rust specific library errors, because then we have to handle Rust specific errors in the calling code location. So instead of doing that, I convert that error to this box new std error, and then send it to the calling location. So for now, we'll just, this is the code we have. In a future session, we'll expand more on the error handling. So the leverage funds, then main.rs has bunch of changes. These are all import. We take the topic. So it's just move the code around. Since now we get the topic from the config file, I had to move the code around. It's just the high-level code changes. Then I updated the main loop. The main loop which will read the messages from NSQ. And I made some code changes here. Since now we are passing, instead of doing unwrap at the library calls, we are passing the result of enum, result enum with either message or the error. Now all our code has to handle those error messages. So we did a lot of match pattern here. So this is again match pattern. So earlier we were getting, so now we get a result message, so the JSON error. Then we match on the result. If it is okay, process it. If it is an error, if we get the message, then we process the message. And then we also added the message.finish.await before continue. In the earlier code, we were just continuing without doing message.finish. And that's the reason NSQ was sending the same message over and over, because we never add the message. Now, before every continue, we do a message.finish. Similarly, here we do some error handling, and then we do message.finish, then continue. And if the continue doesn't, if we don't hit the continue code, and if we reach here, then before we read the next message, we do message.finish. So these are high-level code changes in main.rs. Then model.rs. Earlier we were skipping some SERDI deserialization of error and exception message. Now we removed that, and instead of skip, we put default. So if it is present, it will be serialized and deserialized. If it is not present, it will not. It will just put a default value in the strings. So this way we can avoid exceptions when we get a message from the client which doesn't have an error or error exception or the exception message, because it's a fresh message which is received from the client. Then we did some changes, the similar changes in router. I'll just go over the router service. It's the same service. We again use match pattern. So we match on client.get object. We await it because it's an async call. And if there's a response, we process the message. Again, if it is decompressed is successful, because a message, if we pass a flag called decompress, because if the object is gzip compressed, we decompress the gzip byte. So we do a match pattern. If it's okay, return data, or else error. Again, here we return an error. So in this video, we spent a lot of time on error handling. So in a later session, we'll check if we can use any cargo file, cargo package, which can give us a seamless error handling. But for now, we converted all the errors into stud.io error struct, and we pass only IO error, so that the calling location can always expect one error type. So with that, I'll close today's session. If you have any questions or comments, please reach me out in the YouTube channel or in the discussion tab in the documentation page.